Hello everyone, I am the Boring Historian, and I am here to help you today. I know you use this video to fall asleep, so before that, like the video and subscribe to the channel. Also, where are you from, and what time are you watching? Now get comfortable and relax. In the waning light of a late autumn day in 1066, a strange apparition blazed across the twilight sky above Normandy. The fiery streak, with its luminous tail stretching like a heavenly finger, cast an ethereal glow upon the face of Duke William as he stood among his advisors. While William interpreted the celestial visitor as a divine blessing for his planned invasion of England, across the narrow sea, the Anglo-Saxon King Harold and his subjects trembled with foreboding. The blazing star, what we now know as Halley's Comet, was widely viewed as a harbinger of doom, a celestial messenger foretelling calamity. Within months, Harold lay dead on the battlefield at Hastings, and William the Conqueror claimed the English throne. This tale, immortalized in the Bayeux Tapestry, represents but one instance of medieval Europe's complex relationship with meteorological and astronomical phenomena. For the people of the Middle Ages, the weather was not merely a subject of casual conversation or minor inconvenience, as it often is today. It was, instead, a constant, omnipresent force that shaped nearly every aspect of daily existence, determining whether crops flourished or failed, whether journeys could be undertaken, whether armies could march, and ultimately, whether communities lived or perished. The medieval worldview placed humanity at the center of creation, with the natural world serving as both stage and mirror for human drama. Weather events were rarely understood as random occurrences governed by physical processes. Rather, they were messages, often warnings, from God. A sudden hailstorm might be interpreted as divine punishment for a community's sins. Unseasonable warmth could signal God's favor. Red skies, spectacular auroras, and unusual cloud formations were scrutinized for signs of what was to come. This perspective emerged from a society deeply anchored in Christian cosmology, while simultaneously preserving fragments of ancient knowledge and folk wisdom. The medieval understanding of weather existed at a fascinating intersection of theology, classical learning, and practical observation. Monasteries served as centers of learning, where monks diligently copied ancient Roman and Greek texts on natural philosophy, preserving the works of Aristotle, Pliny the Elder, and Ptolemy. Yet these same institutions also interpreted Scripture as the ultimate authority on natural phenomena, viewing unusual weather as fulfillment of biblical prophecies or divine judgment. For the common people of medieval Europe, the peasants who composed roughly 90% of the population, weather was not simply an abstract theological concept, but a matter of immediate, often desperate concern. A good harvest meant survival, a poor one meant starvation. When dark clouds gathered on the horizon, it was not merely rain they threatened, but potentially the loss of a year's labor and the specter of hunger. Little wonder, then, that a rich tapestry of weather folklore developed across Europe, with communities developing elaborate superstitions and rituals to predict, explain, and even attempt to control meteorological events. The period we call the Middle Ages spanned roughly 1,000 years, from the fall of the Western Roman Empire in the 5th century to the dawn of the Renaissance in the 15th. During this vast stretch of time, Europe experienced significant climatic variations, including the medieval warm period, approximately 950–1250 CE, and the onset of the Little Ice Age, beginning around 1300 CE. These climate shifts, while occurring gradually over generations, nevertheless profoundly influenced medieval society, contributing to both periods of prosperity and devastating famines. Understanding medieval weather superstitions provides a window into the medieval mind, revealing how people made sense of a world that often seemed chaotic and threatening. It illuminates the complex interplay between religion, nascent science, and folk wisdom that characterized medieval thought. Moreover, it allows us to appreciate the practical ingenuity of people who, lacking modern meteorological instruments or satellite imagery, nevertheless developed sophisticated systems for predicting weather changes based on careful observation of natural patterns. In the pages that follow, we will explore the rich and often strange world of medieval weather beliefs. From monks meticulously documenting comets and eclipses in their chronicles, to peasants studying the behavior of animals for signs of approaching storms. From elaborate astrological systems used by court physicians to predict plagues, to the desperate prayers and processions organized in times of drought or excessive rain. We will examine how natural disasters were understood and explained, how weather prediction methods evolved throughout the period, and how these beliefs continue to influence European thought well into the modern era. As we embark on this journey through medieval meteorology, we must remember that for the people we study, the boundary between the natural and supernatural was far more permeable than it is for most of us today. The heavens were not merely the domain of clouds and stars, but the dwelling place of God and his angels. Weather was not simply a physical process, but a means through which the divine will manifest it in the world. Understanding this perspective is essential if we are to comprehend medieval weather superstitions, not as quaint curiosities or primitive misconceptions, but as coherent elements of a worldview in which the material and spiritual realms were intimately connected. As dawn broke over the scriptorium of Jarrow Monastery in the early 8th century, the Venerable Bede, one of the greatest scholars of the early Middle Ages, bent over his parchment by the light of a flickering oil lamp. Around him lay various manuscripts, Latin translations of Aristotle, the encyclopedic works of Pliny the Elder, and fragments of Ptolemy's astronomical treatises. Drawing from these ancient authorities and tempering their wisdom with Christian doctrine, Bede composed his scientific treatise De Natura Rerum, on the nature of things, in which he attempted to explain various natural phenomena, including weather. Comets, he wrote, are stars with flames like hair. They are born suddenly, portending a change of royal power or plague or wars or winds or heat. In this single sentence, Bede encapsulated the medieval approach to understanding nature, a blend of classical knowledge, observational evidence, and supernatural interpretation that viewed natural phenomena as signs with moral and political significance. The scientific understanding of weather in medieval Europe was built upon the crumbling foundations of classical knowledge. When the Western Roman Empire collapsed in the 5th century, much of the sophisticated Greek and Roman learning about natural phenomena was fragmented or lost entirely to Western Europeans. What survived was preserved primarily through the efforts of monastic scribes and scholars in the Byzantine Empire and the Islamic world, who copied and commented upon ancient texts. Aristotle's Meteorologica, written in the 4th century BCE, formed the theoretical backbone of medieval weather knowledge. In this work, Aristotle proposed that weather phenomena resulted from the interaction of 4 elements: earth, air, fire, and water, and their associated qualities: hot, cold, dry, and wet. According to Aristotelian theory, which dominated medieval thought, the earth was surrounded by spheres of air, fire, and ether, with weather occurring in the sublunary realm, the imperfect, changeable zone beneath the moon. Rain, according to this understanding, occurred when water vapor rose from the earth and condensed in the cold upper air. Thunder resulted from the collision of clouds, while lightning was thought to be ignited air. Aristotle's explanations, while often incorrect by modern standards, nevertheless represented attempts to understand weather through natural, rather than purely supernatural causes. Complementing Aristotle's theoretical framework was Pliny the Elder's Natural History, which provided medieval scholars with a vast compendium of weather signs and prognostications. Pliny collected numerous observations about how the appearance of the sun, moon, and stars, along with the behavior of animals, could presage weather changes. Many of these observations, based on generations of practical experience, remained valuable weather indicators, even as the theoretical frameworks explaining them evolved. These classical texts reached medieval scholars in fragmentary form, often through multiple translations and commentaries. A work by Aristotle might be translated from Greek to Syriac, from Syriac to Arabic, and finally from Arabic to Latin, with each translator adding interpretations shaped by their own cultural context. By the time such knowledge reached a monastery in Northern Europe, it had been transformed into something quite different from the original. Medieval understanding of nature was fundamentally shaped by Christian theology, which presented the natural world as God's creation, designed with purpose and meaning. The Bible served as the ultimate authority on natural phenomena, with passages from Genesis, Psalms, Job, and Revelation, providing frameworks for understanding everything from rainbows, a sign of God's covenant after the flood, to storms, manifestations of divine power or wrath. For medieval Christians, weather events were often interpreted as direct divine interventions. Floods could be punishment for sin, reminiscent of Noah's flood. Droughts might be viewed as tests of faith, similar to those endured by the Israelites in the desert. The Book of Revelation, with its apocalyptic imagery of cosmic disturbances preceding the Last Judgment, provided a particularly potent lens through which unusual weather might be viewed. The influential theologian Thomas Aquinas, 1225 to 1274, attempted to reconcile Aristotelian natural philosophy with Christian doctrine, arguing that God typically worked through natural causes rather than by constantly suspending the laws of nature. According to Aquinas, God had established natural laws at creation, and most weather phenomena followed these laws. However, God could and did intervene directly at times through miracles, which included extraordinary weather events. This theological framework allowed for both natural and supernatural explanations of weather. A drought might be explained as the result of atmospheric conditions, while simultaneously being interpreted as divine punishment or testing. Similarly, beneficial rain could be understood both as the result of natural processes and as an answer to prayers and processions. In practical terms, this meant that medieval responses to adverse weather conditions often combined practical measures with religious rituals. During drought, for instance, communities might organize their labor to dig irrigation ditches, while simultaneously conducting processions and prayers for rain. When storms threatened, people would take physical precautions, while also ringing church bells, believed to disperse storm clouds, or placing blessed herbs in their fields. Monasteries played a crucial role in preserving and developing meteorological knowledge throughout the Middle Ages. Monastic life was structured around the agricultural year and the daily cycle of prayers, making accurate timekeeping and calendar calculations essential. This necessity led to a particular interest in astronomy, and by extension, in weather phenomena that might affect observations of the stars. Monks were among the most literate members of medieval society, with access to ancient texts and the time to study them. They were also practical land managers, overseeing large agricultural estates where successful farming depended on understanding weather patterns. This combination of theoretical knowledge and practical necessity made monasteries important centers for weather observation and record-keeping. The Carolingian Renaissance of the 8th and 9th centuries saw a renewed interest in natural philosophy, including meteorology, under the patronage of Charlemagne and his successors. Scholars like Alcuin of York worked to collect and preserve ancient learning, establishing cathedral schools and monastic libraries that would form the foundation for later medieval scientific thought. Monastic chronicles often recorded unusual weather events alongside political developments and ecclesiastical appointments. While these records are not kept primarily for meteorological purposes, they nevertheless provide valuable historical climate data. The Anglo-Saxon Chronicle, for instance, records that in 793 CE, here were dreadful forewarnings come over the land of Northumbria, and woefully terrified the people. These were amazing sheets of lightning and whirlwinds, and fiery dragons were seen flying in the sky. A great famine soon followed these signs, and shortly after, in the same year, the woeful inroads of heathen men destroyed God's church in Lindisfarne Island by fierce robbery and slaughter. Such accounts reveal how weather events were integrated into historical narratives as explanatory devices, connecting natural phenomena with human events through systems of moral causation and divine judgment. While learned monks and scholars debated the theoretical frameworks for understanding weather, ordinary people throughout medieval Europe developed sophisticated systems of weather prediction based on careful observation of natural patterns. Many of these observations were remarkably astute, capturing correlations between observable phenomena and subsequent weather changes that modern meteorology confirms. For instance, the medieval saying, "Red sky at night, shepherd's delight, red sky in morning, shepherd's warning," reflects a genuine correlation between sunset-sunrise colors and approaching weather systems in mid-latitude regions. Similarly, observations about animal behavior before storms, swallows flying low, frogs croaking loudly, cats washing behind their ears, often captured real responses to changes in atmospheric pressure or humidity. These practical observations were passed down through generations as rhymes, proverbs, and folk wisdom. While people might explain these correlations through supernatural frameworks, claiming that animals had divinely granted foreknowledge of weather, for instance, the observations themselves were grounded in genuine patterns. Agricultural calendars and almanacs combined these practical observations with astronomical knowledge, creating systems that helped farmers time their planting, harvesting, and other activities. The observation that certain saints' days often coincided with particular weather patterns, such as the ice saints of mid-May when late frosts might occur, allowed for the creation of a religious calendar that also functioned as a weather guide. By the later Middle Ages, this body of practical knowledge had begun to be systematized in vernacular texts like the Calendarium of Nicholas of Lynn or the various books of hours that contained information on seasonal activities alongside prayers and religious observances. These texts represent an important step in the development of meteorology, bridging the gap between learned Latin treatises and popular oral traditions. Despite the rich mixture of ancient learning, theological frameworks, and practical observation available to medieval people, accurate weather prediction remained challenging. The fundamental limitation was the lack of instruments for measuring atmospheric conditions. Without thermometers, barometers, hygrometers, or other basic meteorological tools, observers relied entirely on what could be perceived with unaided human senses. This limitation was particularly significant for long-term weather prediction, which was much desired in an agricultural society. Various systems emerged to address this need, from the observation of weather on specific days such as Candlemas or St. Swithin's Day, that were believed to predict conditions for weeks or months ahead, to elaborate astrological calculations that attempted to forecast seasonal patterns based on planetary positions. The Venerable Bede contributed significantly to the development of medieval timekeeping and calendar calculation, creating tables that helped determine the date of Easter and other movable feasts. This calendrical work necessarily engaged with astronomical observation and indirectly with weather patterns associated with different seasons. By the 12th and 13th centuries, the translation of Arabic astronomical and astrological texts into Latin had introduced more sophisticated predictive systems to European scholars. These included methods for forecasting weather based on the positions of the moon, planets, and stars at different times of year. While modern meteorology does not recognize celestial influences beyond the sun's radiation and the moon's tidal effects, these systems nevertheless represented attempts to identify long-term patterns in weather phenomena. Despite these various approaches, medieval weather prediction remained more art than science, combining observation, calculation, traditional wisdom, and religious interpretation. When predictions failed, as they often did, explanations could be found in divine intervention, human sin disrupting natural patterns, or the inherent limitations of human knowledge in the face of God's mysteries. The medieval understanding of nature thus existed at a fascinating intersection of practical observation, ancient learning, religious belief, and folk wisdom. It was neither as superstitious as sometimes portrayed, nor as rigorously empirical as modern science. Instead, it represented a coherent worldview in which natural phenomena had both physical causes and moral significance, a perspective that allowed medieval people to make sense of the weather that so profoundly shaped their lives. On a crisp April night in 1066, a hairy star appeared in the skies above Europe, blazing with an unearthly light that outshone even Venus. For nearly a week, this celestial visitor, what we now know was Halley's Comet, dominated the night sky, its fiery tail stretching across the heavens like a divine finger pointing toward judgment. Across Europe, from humble villages to royal courts, people gazed upward with a mixture of awe and terror, certain that such an extraordinary apparition must portend extraordinary events. When comets burn, they signify the death of kings or the coming of a great plague or war, wrote the monk John of Worcester, echoing a sentiment that pervaded medieval thought. In the European medieval worldview, comets were not merely astronomical phenomena but messengers, typically bearers of calamitous tidings. They were seen as disruptions in the perfect, unchanging harmony of the heavens, intrusions that signaled corresponding disruptions in the earthly realm. The Venerable Bede, writing in the early 8th century, described comets as stars with flames like hair that appeared suddenly, portending a change of royal power, or plague, or wars, or winds, or heat. This description captures the essential medieval understanding of comets. They were unpredictable, visually striking, and most importantly, pregnant with meaning for human affairs. This belief was not uniquely European. Chinese astronomers had been carefully recording comet appearances for centuries, with the oldest observations dating back to the 11th century BCE. Their records, preserved in works like the Divination by Astrological and Meteorological Phenomena from the Western Han Dynasty, linked specific comets to specific calamities: the 3-year drought, the coming of the plague, or the death of the prince. What made comets particularly fearsome in the medieval imagination was their apparent unpredictability. Unlike the sun, moon, and visible planets, whose movements followed recognizable patterns, comets seemed to appear without warning, defying the orderly celestial mechanisms described by Aristotle and Ptolemy. This unpredictability, combined with their striking appearance, marked them as supernatural rather than natural phenomena, direct messages from God rather than regular components of the created order. Of all the comets observed in medieval times, none had a more profound impact on European history than Halley's Comet, which returns approximately every 76 years. Though not recognized as a single recurring object until Edmund Halley's calculations in the 18th century, this comet's appearances were recorded throughout the medieval period, each time accompanied by reports of disasters and upheavals. The 1066 appearance of Halley's Comet is perhaps the most famous, immortalized in the Bayeux Tapestry, where it appears above King Harold's head with the caption, Isti mirant stella, they marvel at the star. The comet was widely interpreted as an omen of Harold's downfall and William the Conqueror's divinely sanctioned victory. Aylmer of Malmesbury, an elderly monk who had seen the comet during its previous appearance in 989, reportedly exclaimed, "You've come, have you? You've come, you source of tears to many mothers. I hate you. It is long since I saw you, but as I see you now, you are much more terrible, for I see you brandishing the downfall of my country." True to medieval expectations, the comet's appearance was indeed followed by momentous events. William's conquest of England, which fundamentally altered the course of English history, language, and culture. This apparent confirmation of the comet's prophetic significance reinforced the belief in comets as harbingers of political change. When Halley's Comet returned in 1145, it coincided with the fall of Edessa to Muslim forces, a pivotal event that prompted the Second Crusade. Its 1222 appearance occurred during the Mongol invasions that devastated Eastern Europe. The 1301 sighting is said to have inspired Giotto's depiction of the Star of Bethlehem in his fresco, Adoration of the Magi, in the Scrovegni Chapel. A rare positive interpretation of a comet as the Star of Bethlehem, rather than a portent of doom. With each appearance, Halley's Comet accumulated additional layers of fearful association, becoming emblematic of the medieval belief that celestial phenomena directly influenced earthly events. That this particular comet returned at intervals roughly equivalent to a human lifetime meant that few people ever saw it twice. It remained, for most, a singular, extraordinary event, rather than part of a predictable pattern. While most medieval comets reinforced traditional beliefs about celestial omens, the Great Comet of 1577 ultimately helped undermine these very beliefs. Appearing in November 1577, this spectacular comet was as bright as Venus, and displayed a tail stretching across a portion of sky 40 times the diameter of the full moon. The Danish astronomer Tycho Brahe seized upon this extraordinary opportunity to make precise observations of the comet from his observatory at Uraniborg. By comparing his measurements with those made by other astronomers across Europe, Brahe determined that the comet showed no measurable parallax, meaning it must be at least 4 times more distant than the moon. This discovery directly challenged the Aristotelian cosmology that had dominated Western thought for nearly 2 millennia. Aristotle had claimed that comets were atmospheric phenomena occurring between the Earth and the moon, windy exhalations in the sublunary sphere. Brahe's observations proved conclusively that comets were celestial objects moving among or beyond the planets. While the full implications of this discovery would not be realized until after the medieval period, Brahe's work on the Great Comet of 1577 marks a crucial turning point in the understanding of comets. It represents the beginning of a shift from viewing comets as supernatural omens to seeing them as natural objects governed by the same physical laws as planets and stars. Nevertheless, the superstitious fear of comets persisted well beyond the Middle Ages. As late as 1910, Halley's Comet's return caused mass hysteria when astronomers detected cyanogen in its tail, leading to fears that the Earth's passage through the tail would poison the atmosphere. Newspapers reported panic buying of comet pills and gas masks, while some people attempted to seal their homes against the toxic gases from space. Throughout the medieval period, monks and other literate observers carefully documented comet appearances in chronicles and annals. These records often juxtaposed comet sightings with subsequent disasters, reinforcing the perceived connection between celestial and earthly events. The Anglo-Saxon Chronicle entry for 729 CE reports, "In this year the star called Comet appeared, and Saint Egbert passed away." For 892 it notes, "And the same year after Easter, about Rogation days or earlier, appeared the star which in Latin is called cometa." Some men say in English that it is a long-haired star, because a long beam of light shines from it, sometimes on the one side, sometimes on the other. These monastic records served multiple purposes. They preserved observations for future reference, integrated unusual natural phenomena into Christian historical narratives, and helped establish patterns that could guide interpretations of future appearances. By recording which disasters followed which comets, chroniclers created a kind of historical database that could be consulted when new comets appeared. The detail and accuracy of these records varied considerably. Some chroniclers provided precise dates, careful descriptions of a comet's appearance and movement, and subsequent events potentially linked to the comet. Others offered only brief mentions or focused primarily on the theological significance of the apparition. By the later Middle Ages, some chronicles show evidence of more systematic observation. The English chronicler Matthew Paris, writing in the 13th century, included detailed drawings of comets alongside his text, attempting to capture their visual appearance with unprecedented accuracy. Such illustrations represent early steps toward a more scientific approach to comet observation, though they remained embedded within a framework that interpreted comets primarily as omens. When a comet appeared in medieval skies, common responses included intensified religious observances, precautionary measures against anticipated disasters, and sometimes panic or extraordinary behavior. Church bells might be rung continuously to ward off the comet's influence. Special masses, processions, and prayers would be organized to beg divine mercy. In some cases, comets prompted outbreaks of apocalyptic fervor or religious enthusiasm. The appearance of Halley's Comet in 684 CE coincided with a wave of pilgrims traveling to Rome, while its 1066 appearance may have contributed to the sense of apocalyptic anticipation that some historians have identified in European society around the first millennium. For medieval rulers, comets posed particular challenges. Kings and emperors were believed to have special connections to the cosmic order, making them especially vulnerable to celestial omens. A comet might be interpreted specifically as predicting a monarch's death or overthrow, potentially destabilizing their rule, regardless of whether such disasters actually followed. Some rulers responded by commissioning special prayers, making donations to religious institutions, or undertaking pilgrimages to demonstrate their piety and potentially avert disaster. Others consulted astrologers for more specific interpretations of what the comet might mean for their reign and what actions might mitigate negative influences. Medieval fear and fascination with comets left significant traces in art and literature. The Bayeux Tapestry's famous depiction of Halley's Comet above a group of awestruck observers and King Harold on his throne is perhaps the most famous artistic representation of a medieval comet. The embroidered image shows the comet with a flaming tail, emphasizing its ominous, fiery nature. In manuscript illuminations, comets typically appear as stars with flowing, flame-like tails. They often feature in illustrations of the apocalypse or other eschatological scenes, reinforcing their association with the end times. Some medieval world maps and celestial charts include comets, usually placed among the symbols for various disasters or divine judgments. Literary references to comets abound in medieval texts, from chronicles to poems to theological treatises. Geoffrey Chaucer, writing in the late 14th century, referred to comets as the heavenly crime in his poem Annalita and Arcite, reflecting the persistent view of comets as disruptions in the perfect celestial order. In the Divine Comedy, Dante associates comets with Mars and the god of war, reinforcing their connection with conflict and bloodshed. Throughout medieval literature, comets function as powerful symbols of impending disaster, divine communication, or cosmic disorder. The medieval understanding of comets as supernatural omens began to erode during the scientific revolution of the 16th and 17th centuries. Tycho Brahe's observations of the Great Comet of 1577 demonstrated that comets were superlunar phenomena, contradicting Aristotelian cosmology. Johannes Kepler's laws of planetary motion and Isaac Newton's theory of universal gravitation provided a framework for understanding comets as natural objects following predictable orbits. The decisive moment in the transition from superstition to science came when Edmund Halley used Newton's principles to calculate the orbits of several comets observed between 1531 and 1682. Recognizing similarities in their orbits, Halley predicted that these were appearances of the same comet, which would return in 1758. Though Halley did not live to see it, the comet's return as predicted confirmed that comets were regular celestial objects governed by the same laws that guided planetary motion. Nevertheless, superstitious fears about comets persisted well into the modern era. The panic surrounding Halley's comet in 1910 demonstrated that ancient anxieties could resurface even in an age of scientific enlightenment. As recently as 1997, the Heaven's Gate cult interpreted Comet Hale-Bopp as a sign to commit mass suicide, believing an alien spacecraft was following behind the comet to take their souls to another level of existence. The medieval belief that comets heralded disaster contains a kernel of truth, though not in the way medieval observers imagined. Modern science has identified several ways in which comets could indeed bring catastrophe to Earth, not as supernatural omens, but as physical objects that could potentially collide with our planet, as the Tunguska event of 1908 and the Chelyabinsk meteor of 2013 reminded us. In this sense, the medieval fear of comets as harbingers of disaster was not entirely misplaced, even if the causal mechanism they imagined, divine warning or punishment, differs from our current understanding. Their careful observation and recording of comets, motivated by superstitious fear, nevertheless contributed valuable data to the astronomical record that later scientists would use to develop more accurate models of cometary behavior. The medieval fascination with comets thus represents both the limitations of pre-scientific cosmology and the persistent human desire to find meaning in celestial phenomena. It reminds us that the boundary between superstition and science is not always as clear-cut as we might imagine, and that our current understanding of comets and other astronomical phenomena builds upon centuries of observation, motivated by a complex mixture of fear, curiosity, and wonder. On a summer morning in a medieval English village, a farmer pauses at the threshold of his cottage, studying the behavior of his animals before deciding whether to begin the hay harvest. His chickens scratch in the dust rather than taking shelter, suggesting no immediate rain. Swallows dart high in the clear sky, another good sign. But he notices frogs croaking unusually loudly from the nearby pond, and his old hound seems restless, repeatedly turning in circles before lying down. Most telling of all, the ants near his doorstep have built up the soil around their hill, a sure sign of approaching wetness. The farmer decides to delay the harvest, heeding the warnings written in the behavior of the creatures around him. This scene, though imagined, reflects the reality of medieval weather forecasting, where careful observation of animal behavior served as one of the most reliable methods for predicting short-term weather changes. In an era without barometers, thermometers, or satellite imagery, medieval people relied heavily on natural indicators, with animal behavior among the most trusted. The medieval belief in animals as weather prophets was not merely superstition, but rested on generations of practical observation. Many animals are indeed sensitive to changes in atmospheric pressure, humidity, and electrical charges that precede weather changes, sensitivities that human beings generally lack without technological assistance. When medieval farmers or sailors observed that certain animal behaviors reliably preceded certain weather conditions, they were recognizing genuine correlations, even if they might explain these correlations through frameworks we now consider unscientific. Medieval weather lore concerning animals combined practical observation with religious and classical influences. The Bible provided precedents for animals serving as divine messengers. Noah's dove bringing the olive branch, Balaam's talking donkey, the ravens feeding Elijah. Classical sources like Pliny's Natural History and Aristotle's History of Animals catalog numerous instances of animals predicting weather changes. These authoritative texts reinforced and systematized folk observations passed down through generations. Birds occupied a privileged position in medieval weather prediction. Their ability to fly placed them closer to the heavens, the source of weather, while their evident sensitivity to atmospheric changes made them particularly reliable indicators. Swallows received special attention in medieval weather lore. When swallows flew high, fair weather was expected. When they skimmed low over water or ground, rain was thought imminent. This correlation is scientifically sound. Swallows feed on flying insects, which fly higher in high-pressure conditions associated with clear weather, and lower when falling pressure preceding storms forces down the tiny air plankton they feed upon. The 13th century scholar Bartholomeus Anglicus wrote in his Encyclopedia De Proprietatibus Rerum on the properties of things. When swallows fly high in the clear air, it betokens fair weather. But when they fly low, touching the water with their wings, it signifies rain. Similar observations appeared in agricultural almanacs and the marginalia of monastic manuscripts throughout the medieval period. Roosters, too, played an important role in weather prediction. A medieval English weather rhyme advised, "If the cock crows going to bed, he will certainly rise with a watery head." Unseasonable or unusual crowing was widely interpreted as presaging weather changes, particularly storms. Modern studies have confirmed that roosters can indeed respond to barometric pressure changes, though their crowing is influenced by many other factors as well. Seabirds held particular significance for coastal communities and sailors. Petrels, gulls, and other marine birds coming inland were interpreted as a warning of approaching storms at sea, an observation consistent with these birds' tendency to seek shelter ahead of dangerous weather. The 14th century sailor's rhyme, "Seagull, seagull, sit on the sand, it's a sign of rain when you're on the land," captures this widespread belief. Water birds like ducks and geese were thought to predict the severity of coming winters. According to medieval folklore, if wild geese flew high in an orderly formation in autumn, a mild winter would follow. If they flew low and in disarray, a harsh winter was expected. The behavior of resident ducks, particularly their feather oiling activity, was interpreted as indicating imminent rainfall. Beyond these specific examples, medieval weather lore recognized that unusual agitation, calling, or migration patterns among birds generally signaled weather changes. Many of these correlations have scientific basis. Birds' hollow bones make them sensitive to pressure changes, while their dependence on flight makes them particularly attuned to atmospheric conditions. For medieval peasants, the behavior of familiar domestic animals provided daily weather guidance. Cats, dogs, cattle, sheep, and other livestock all featured prominently in weather folklore. Cats received particular attention. A cat washing its face was believed to predict rain if the paw was brought behind its ear. Modern explanations suggest that rising humidity before rainfall may indeed cause cats to groom more frequently due to discomfort from static electricity in their fur. The medieval saying, "When cats purr and wash, bad weather is at hand," persisted well into modern times. Dogs digging in the ground or appearing restless were thought to foretell storms or significant weather changes. This belief likely stems from dogs' sensitivity to changes in atmospheric pressure and their ability to hear low-frequency sounds, like distant thunder, inaudible to humans. The 14th century Book of Secrets, attributed to Albertus Magnus, notes, "When dogs roll on the ground and smell it more than customary, it foretells rain and storms." Cattle and sheep provided important weather indicators for agricultural communities. Cattle huddling together or lying down in fields during the morning were thought to predict rain later in the day. Sheep turning their backs to the wind often indicated approaching precipitation. These behaviors have been confirmed by modern ethologists as responses to falling pressure and increasing humidity preceding rainfall. Even smaller domestic animals like rabbits and poultry were enlisted as weather prognosticators. Rabbits feeding later in the evening than usual or remaining unusually active were interpreted as signs of fair weather to come, while chickens seeking shelter or dust bathing vigorously suggested approaching rain. The practical value of these observations is evident in their persistence across centuries and cultures. Many remain embedded in folk wisdom today, and some have been validated by scientific study. What distinguishes medieval interpretation from modern understanding is not the observed correlation, but the explanatory framework. Medieval people might attribute an animal's weather sensitivity to divine design or special knowledge granted by God, while we explain it through evolutionary adaptations and heightened sensory capacities. Some of the most reliable weather indicators in medieval folklore came from the smallest creatures. Insects, spiders, frogs, and worms all provided valuable meteorological information to attentive observers. Ants received particular attention. The 13th century Book of Knowledge notes, "When ants move their eggs from low ground to high ground, expect floods. When they clear their hills and arrange them more perfectly, expect fair weather." These observations accurately reflect ant behavior. Many species do indeed move their eggs to higher ground before heavy rainfall, and engage in hill maintenance during fair weather. Spiders and their webs offered especially reliable weather signs. According to medieval weather lore, spiders spinning new webs indicated fair weather, while spiders hiding suggested storms approaching. The construction, size, and positioning of spider webs were all thought to provide weather information. If spiders are active in their webs during rain, that rain will soon cease, but if they remain hidden, the rain will continue. Advises a 15th century agricultural manual. Bees were closely observed by medieval beekeepers, who noted that bees returning rapidly to hives often preceded rainfall, while bees flying far afield suggested continuing fair conditions. The medieval beekeeper's adage, "A swarm of bees in May is worth a load of hay," connected bee behavior not just with immediate weather, but with seasonal patterns affecting agriculture. Frogs, with their dual existence in water and on land, held special significance as weather prophets. Frogs croaking more loudly or abundantly than usual was widely recognized as a sign of approaching rain, a correlation supported by modern understanding of how humidity affects frog vocalization. The 12th century physician and naturalist Hildegard of Bingen wrote that, "When frogs croak more than customary from the marshes, rain will come within 3 days." Worms emerging from the soil in large numbers were correctly interpreted as signs of significant rainfall approaching. We now understand this behavior as an adaptive response to avoid drowning when soil becomes saturated. But medieval observers simply recognized the reliable correlation between surfacing worms and imminent downpours. These examples demonstrate how medieval people developed sophisticated weather prediction systems based on careful observation of even the smallest creatures. While they might attribute these behaviors to divine design or special knowledge granted to animals, the correlations themselves were often remarkably accurate. Medieval hunters and foresters developed specialized knowledge about how wild animal behavior related to weather changes. This wisdom became integrated into broader weather lore and hunting practices. Wolves howling during clear weather were thought to predict storms, while wolves moving to higher ground warned of potential flooding. The behavior of deer before storms, feeding in open areas rather than remaining in forest cover, was noted by hunters as a reliable indicator of approaching poor weather, allowing them to plan expeditions accordingly. Bears, where present in medieval Europe, were believed to build more substantial dens before particularly harsh winters, an observation consistent with bears' actual behavior when environmental cues suggest severe conditions ahead. Similarly, squirrels gathering nuts earlier or in greater quantities than usual were interpreted as predictions of hard winters. Fox behavior featured prominently in rural weather lore. Foxes barking loudly at night were thought to herald rain, while foxes hunting in daylight during winter suggested continuing cold. The medieval hunting manual, Master of Game, advises, "When foxes bark clearly at night and smell more strongly than usual, rain and wind will follow soon." Even fish behavior informed medieval weather prediction. Fish jumping more frequently than normal or surfacing in unusual numbers were widely interpreted as signs of approaching storms, a correlation that modern science attributes to changes in water pressure and oxygen levels preceding weather systems. These observations were particularly valuable because they extended the predictive window beyond what human senses alone could achieve. While people might notice clouds gathering or winds shifting hours before a storm, animal behavior could provide warnings days in advance, allowing crucial time for preparation. Medieval weather predictions based on animal behavior existed at a fascinating intersection of practical observation and religious or supernatural interpretation. While the observations themselves often captured genuine correlations between animal behavior and subsequent weather patterns, the explanatory frameworks reflected medieval cosmology and theology. When medieval people observed frogs croaking more vigorously before rain, they correctly recognized a reliable weather indicator. However, they might explain this behavior by suggesting that frogs, as creatures associated with water, possessed special divine knowledge of coming rain, or that their amphibious nature granted them privileged access to both terrestrial and aquatic realms. In Christian interpretations, animals might be seen as fulfilling their God-given roles in the created order. serving as weather messengers for human benefit. The 12th century abbess and naturalist Hildegard of Bingen attempted to systematize animal weather lore within a Christian framework. In her works Physica and Causae et Curae, she described numerous animal behaviors as weather indicators, while explaining these correlations as manifestations of divine wisdom. God had created animals with instinctive knowledge of coming weather, she argued, as part of his providential care for creation. While the religious framework may differ from modern scientific explanations, the medieval approach to animal weather prediction demonstrated genuine ecological awareness and careful observation of the natural world. Medieval farmers, sailors, and travelers developed nuanced understanding of how different animals behaved before different types of weather, creating complex predictive systems that serve practical needs in a world without modern meteorological instruments. Many medieval animal weather predictions have persisted into modern folklore, suggesting their practical utility. The English rhyme, "Red sky at night, shepherd's delight, red sky at morning, shepherd's warning," remains widely known, as does the belief that cows lie down before rain. The Groundhog Day tradition in North America derives directly from European animal weather lore, specifically German beliefs about badgers predicting the length of winter. This persistence attests to the genuine observational basis of many animal weather predictions. When stripped of supernatural explanations, many medieval weather beliefs captured genuine correlations between animal behavior and atmospheric changes. Correlations that modern science confirms are based on animals' sensitivity to barometric pressure, humidity, electromagnetic fields, and other pre-storm conditions undetectable to human senses without technological assistance. The medieval approach to animal weather prediction thus represented a sophisticated attempt to systematize natural knowledge within available explanatory frameworks. It combined careful empirical observation with religious interpretation, creating a coherent system that helped people navigate a world where accurate weather prediction could mean the difference between life and death. On a May morning in 1230, darkness fell across Europe. The sun, which had risen normally, began to diminish as a black shadow crept across its face. Within hours, panic gripped villages, towns, and cities across the continent. Church bells rang frantically to ward off whatever evil was consuming the daylight. Some people fell to their knees in prayer, convinced the end of the world had arrived. Others confessed sins or reconciled with enemies, preparing for imminent judgment. What they were witnessing was a total solar eclipse, a relatively rare astronomical event where the moon passes directly between the Earth and Sun, temporarily blocking sunlight. For modern observers with our understanding of celestial mechanics, eclipses are awe-inspiring but explainable natural phenomena. For medieval Europeans, they represented profound disruptions in the cosmic order, often interpreted as divine warnings or omens of disaster. The 13th century chronicler Matthew Paris described the 1230 eclipse. On the morrow of the feast of Saint Urban, on the 6th day of the week, at the 9th hour, there was an eclipse of the sun which was wondrous and terrible. For the day was turned to night, stars appeared in the sky, and objects on the ground could not be discerned. Men and women were struck with fear, saying that the last judgment was nigh. Solar eclipses held particular significance in medieval cosmology because they inverted the natural order, turning day to night, light to darkness. In a worldview where the heavens represented divine perfection and order, such disruptions could only signify extraordinary events on Earth. Chronicles throughout the medieval period record eclipses alongside accounts of subsequent disasters, reinforcing the perceived connection. The Anglo-Saxon Chronicle entry for 664 CE reports, "In this year the sun was eclipsed on the 5th of May, and Ersenbrecht, king of Kent, died, and Colman, with his companions, went to his native land. And that same year there was a great pestilence in the island of Britain. This pestilence, likely an outbreak of bubonic plague, was widely interpreted as having been foretold by the eclipse." Lunar eclipses, though less dramatic, carried similar ominous associations. The reddish appearance of the moon during total lunar eclipses, caused by Earth's atmosphere filtering sunlight onto the lunar surface, evoked biblical prophecies about the moon turning to blood before the Day of Judgment. The 14th century chronicler John Froissart noted that a blood-red lunar eclipse in 1349 was widely interpreted as confirming that the Black Death sweeping Europe represented divine punishment. Medieval scholars, drawing on Aristotle, Ptolemy, and other classical sources, understood the basic mechanics of eclipses. The Venerable Bede correctly explained in the 8th century that lunar eclipses occur when the moon runs into the Earth's shadow, solar eclipses when the new moon passes between the sun and Earth. However, this natural explanation did not diminish the event's significance as a divine sign. Understanding the mechanism by which God delivered warnings did not make them any less portentous. When predictable astronomical events like eclipses appeared to foretell unpredictable earthly disasters, medieval thinkers saw evidence of God's sovereignty over both the heavenly and terrestrial realms. The cosmic machinery operated according to divine design, with celestial anomalies deliberately timed to precede earthly calamities as warnings or explanations. If eclipses represented temporary disruptions in the cosmic order, other atmospheric phenomena like auroras, sun halos, and unusual cloud formations were equally significant as potential omens. The northern lights, aurora borealis, visible even in southern European regions during periods of intense solar activity, inspired particular awe and foreboding. A vivid description from the Annals of Ulster for the year 772 CE reports, "A horrible and wonderful sign was seen in the stars at night. Fiery streams appeared which seemed to fight among themselves in the air, taking a blood-red hue." The following year, the same chronicle records widespread famine and disease, reinforcing the aurora's interpretation as a warning. Medieval observers described auroras in terms of fighting armies, flaming spears, or rivers of blood in the sky. Such martial imagery reflects both the visual appearance of auroras and their interpretation as portents of coming conflict. The 12th century Icelandic saga, Grenlandinga Saga, recounts how an aurora seen over Greenland in the late 10th century was interpreted as an omen of bloodshed, a prophecy fulfilled when conflicts erupted between Norse settlers and indigenous Skrælings. Other atmospheric phenomena received similar treatment. Solar halos, rings around the sun caused by ice crystals in high atmosphere, were interpreted as divine crowns or celestial portals. The appearance of multiple suns, sun dogs or parhelia, bright spots created by sunlight refracting through ice crystals, often heralded political divisions or challenges to royal authority. When 3 suns appeared in the sky in 1461 before the Battle of Mortimer's Cross during England's Wars of the Roses, the Yorkist commander Edward, Earl of March, later King Edward IV, interpreted them as representing the Holy Trinity blessing his cause, turning a potentially frightening omen into a favorable one for his troops. Unusual cloud formations received particular scrutiny. Cloud shapes resembling animals, armies, or monsters were carefully observed and interpreted. The medieval English chronicler Ralph of Coggeshall recorded that in 1205, on the evening of the Epiphany, there were seen in the sky 5 moons, a large one in the middle, and 4 small ones around it, with stars between them. This lasted for about an hour, and it signified, as some said, that the King of England would be surrounded by rebel subjects and enemies. The phenomenon he described was likely a complex lunar halo with associated optical effects, but its interpretation focused on its perceived political significance. Even ordinary rainbows carried significance beyond their meteorological cause. While the biblical account of Noah established rainbows as signs of God's covenant never again to destroy the world by flood, medieval interpretations often went further. Rainbows appearing at crucial moments might be interpreted as divine approval or protection. Conversely, unusually positioned or colored rainbows could signify discord or coming strife. These interpretations were not merely superstitious panic, but represented attempts to integrate unusual natural phenomena into a coherent worldview where the physical and spiritual realms remained intimately connected. Even educated observers who understood the natural causes of such phenomena could simultaneously interpret them as divinely arranged signs. Few weather phenomena inspired as much religious awe and fear in medieval Europe as thunder and lightning. The raw power of thunderstorms, their ability to strike down the mighty regardless of social status, and their association with rainfall, necessary for crops, made them perfect vehicles for divine communication in the medieval imagination. Throughout medieval religious art, God and saints were frequently depicted with thunderbolts or surrounded by storm clouds, drawing on both biblical imagery and classical precedents like Zeus, Jupiter. The Old Testament described God speaking through thunder and appearing in storms, while various saints, particularly Saint Barbara, were associated with protection against lightning. The instantaneous nature of lightning, its ability to strike without warning and inflict devastating damage, made it particularly apt as a symbol of divine judgment. When lightning struck prominent buildings, especially churches or palaces, medieval chroniclers inevitably interpreted these events as meaningful rather than random. The Anglo-Saxon Chronicle reports that in 1077, lightning came at midnight and went to Combe and burned many villas and also many men, and it did damage in many places. The specific targeting of certain locations was seen as evidence of divine intent rather than chance. Lightning strikes on churches posed particular theological challenges. Why would God damage his own house? Medieval explanations varied, from suggesting that demons had been permitted to cause the damage as a test of faith, to arguing that particular congregations or clergy had become corrupted and required dramatic warning. When lightning repeatedly struck Old St. Paul's Cathedral in London throughout the medieval period, various interpretations emerged, from signs of divine displeasure with church corruption to warnings against specific theological positions. Medieval attempts to mitigate lightning damage revealed the complex interplay between religious and practical responses to weather threats. Church bells were rung during thunderstorms, a practice that combined practical community warning with the belief that consecrated bells could disperse storms. Despite the obvious danger to bell ringers in tall, often metal-topped bell towers, the Latin inscription commonly found on medieval bells, Fulgura frango, I break up the lightning, reflects this dual purpose. Other protective measures included placing blessed herbs or palm branches in homes, reciting prayers to Saint Barbara or other protective saints, and displaying various protective amulets. Some communities maintained the pre-Christian practice of placing axes or other iron tools outside during storms, believing metal objects would attract lightning away from buildings, a rudimentary form of lightning rod based on practical observation rather than theoretical understanding. Thunder itself, the acoustic aftermath of lightning, received equally careful interpretation. Different qualities of thunder suggested different messages. Rolling thunder might indicate God's distant warning, while sharp cracks suggested immediate judgment. Unseasonable thunder, such as during winter months, was particularly ominous, often interpreted as presaging political upheaval or unusual weather in the coming season. The 13th century monk and natural philosopher Albertus Magnus attempted to provide a comprehensive theory of thunderstorms that incorporated both Aristotelian meteorology and Christian theology. He explained that thunder resulted from the explosive meeting of hot and cold exhalations in the atmosphere, a natural process, but maintained that God arranged these natural processes to occur at specific times as signs or punishments. This approach, reconciling natural causation with divine purpose, typifies the sophisticated medieval approach to weather phenomena. By the later Middle Ages, astrological weather prediction had developed into a sophisticated system integrating classical learning, Arabic astronomical advancements, and Christian theology. While early church fathers had condemned much of astrology as pagan fatalism, incompatible with Christian free will, a modified form of astrology emerged that viewed celestial influences as one of many natural forces God had built into creation. This natural astrology, focused on general predictions rather than individual horoscopes, became increasingly acceptable in Christian intellectual circles, particularly for weather forecasting. The logic was straightforward. If the moon could obviously affect tides, and the sun controlled the seasons, why shouldn't other celestial bodies influence atmospheric conditions? By the 12th century, translations of Arabic astrological texts had introduced European scholars to more sophisticated systems of astrological weather prediction. Works like the Kitab Amtar wal Asar, Book of Rains and Prices, by the 9th century astrologer Abu Mashar, became available in Latin, providing detailed methods for predicting rainfall, temperature, and winds based on planetary positions and conjunctions. Medieval astrological weather forecasting focused particularly on the positions of the moon and planets relative to different zodiac signs, each associated with particular weather tendencies. For instance, the 13th century astrologer Guido Bonatti wrote that when the moon is in Aquarius, especially in winter, it portends rain or snow. Fire signs Aries, Leo, Sagittarius generally indicated hot, dry conditions. Water signs Cancer, Scorpio, Pisces suggested rain or snow. Earth signs Taurus, Virgo, Capricorn typically meant cold, and air signs Gemini, Libra, Aquarius were associated with wind. Planetary conjunctions, when two or more planets appeared to come together in the sky, received particular attention as potential harbingers of extreme weather. The Great Conjunction of Jupiter and Saturn, occurring approximately every 20 years, was especially significant, with different zodiacal positions indicating different weather patterns for years to come. The 1345 conjunction of Jupiter, Saturn, and Mars in Aquarius was widely interpreted as presaging unusual weather patterns, an interpretation seemingly confirmed by the unusual weather preceding the Black Death a few years later. The development of astrological weather forecasting represented an attempt to move beyond short-term prediction based on immediate signs to longer-term, systematic forecasting. Annual almanacs began to include monthly weather predictions based on astrological calculations, alongside agricultural advice and saints' days. While modern meteorology has discarded astrology as a predictive system, these early attempts at systematic forecasting represent important steps toward a more scientific approach to weather prediction. For medieval people, astrological weather forecasting offered several advantages over other methods. It provided longer forecasting horizons than animal behavior or immediate sky observation. It presented weather patterns as part of an orderly, predictable cosmic system, rather than as arbitrary divine interventions. And it offered the comfort of a universal system integrating celestial and terrestrial phenomena within a coherent framework. The medieval fascination with celestial omens and portents thus represents more than simple superstition. It reflects a sophisticated attempt to integrate empirical observation, classical learning, and religious understanding into a coherent system for interpreting the world. While modern meteorology has replaced these systems with scientific models based on atmospheric physics, the medieval approach reminds us that weather prediction has always served both practical and existential needs, helping people not only prepare practically for coming conditions, but also make sense of their place in a complex and sometimes frightening cosmos. In the bitter winter of 1076 to 1077, the monk John of Worcester sat in the cold scriptorium of his monastery, recording the year's unusual weather in the community's chronicle. "A mighty famine, a season of devastation," he wrote. "Earth fruits unforthcoming, excessive weather abnormalities, terrible thunderings and lightnings. A great comet appeared. Surely it must be considered an indication of some remarkable and dreadful event." John's meticulous recording of weather phenomena alongside political events typifies the crucial role monasteries played in preserving, interpreting, and developing meteorological knowledge throughout the Middle Ages. These religious communities, with their emphasis on routine, literacy, and cosmic order, provided ideal environments for consistent weather observation and record-keeping across generations. The Benedictine rule, which structured life in most Western European monasteries, emphasized regular patterns of prayer, work, and study, synchronized with natural cycles of day and night, seasons, and agricultural necessities. This integration of religious observance with natural rhythms made monasteries particularly attentive to weather patterns and variations. Monastic communities typically maintained chronicles recording significant events, both within the monastery and in the wider world. Weather extremes, unusual phenomena, and their consequences featured prominently in these records. The Worcester Chronicle, the Annals of Ulster, the Chronicle of Novgorod, and dozens of other monastic records across Europe preserve descriptions of storms, droughts, floods, and celestial events that modern climate historians now mine for evidence of medieval weather patterns. Beyond simple record-keeping, monasteries served as repositories for ancient meteorological knowledge. Through the early Middle Ages, monastic scriptoria preserved fragments of classical works on weather and natural philosophy that might otherwise have been lost. Pliny's Natural History, Aristotle's Meteorologica, Seneca's Natural Questions, and other texts survived primarily through monastic copying efforts, preserving ancient weather wisdom for later generations. Monasteries also developed practical expertise in weather-sensitive activities. Many monastic communities derived income from agriculture, making weather prediction valuable for planning planting, harvesting, and storage. Monastic brewing, winemaking, and cheese production all required attention to seasonal patterns and temperature conditions. Even liturgical timing, when to celebrate the movable feast of Easter, for instance, required astronomical observations related to weather calculation. By the later Middle Ages, some monastic communities had developed sophisticated weather observation systems. Durham Cathedral Priory, for instance, maintained detailed records of wind direction, precipitation, and temperature effects from the 13th century onward. The Cistercian Abbey of Revels in Yorkshire located its buildings to optimize natural heating and cooling based on prevailing wind patterns, evidence of practical meteorological knowledge informing monastic architecture. For medieval clergy, weather interpretation occupied a complex theological space. On one hand, Christianity had explicitly rejected the pagan practice of worshipping weather deities or treating natural phenomena as gods themselves. On the other hand, the Bible clearly presented weather events as vehicles for divine communication and judgment, from the flood of Noah to the plagues of Egypt to the storm that spoke to Job. Medieval priests and monks developed nuanced frameworks for interpreting weather as divine communication without slipping into paganism or deterministic fatalism. St. Augustine's influential distinction between natural signs, like smoke indicating fire, and given signs, deliberately created to communicate, provided a useful model. Weather could function as both, operating through natural causes while simultaneously serving as divine communication. This perspective appears clearly in a sermon by the Anglo-Saxon abbot Elfric of Hynsham, c. 955 to 1010, following a series of Viking raids and crop failures. These misfortunes have not happened by chance, but are a sign that God's anger hangs over us, ready to strike. It is now very necessary for us all that we should pray to God Himself for mercy and protection. For Elfric, adverse weather represented both punishment for sins and warning to repent before worse consequences followed. Monastic chronicles frequently made explicit connections between weather disasters and moral failings. The Annals of Ulster, recording a violent storm in 913 CE, notes a great windstorm on the feast of St. Martin, which devastated churches and houses throughout Ireland, a sign of God's anger at the sins of the people. This interpretive framework provided both explanation for suffering and hope for mitigation through spiritual remedies. The medieval clergy particularly emphasized collective rather than individual responsibility for weather disasters. While modern Western perspectives often focus on personal consequences, medieval interpretations stressed community culpability and response. When drought threatened crops, an entire village might process through the fields with relics, led by local priests who called for communal repentance. This collective approach reflected theological understanding that while original sin had disturbed humanity's relationship with nature, Christ's redemption permitted restoration of proper relationship through proper worship. Adverse weather might represent God's punishment, but liturgical response could potentially restore divine favor, making correct religious interpretation and practice literally matter of life and death. This perspective appears clearly in responses to the extreme weather of the early 14th century, when a series of failed harvests preceded the Black Death. Chroniclers like John de Venette explicitly connected unusual weather with divine punishment. In the year of our Lord, 1347, the judgments of God became clearly manifest, first shown in the air through extraordinary change, then demonstrated through mortality among men. By the 12th and 13th centuries, the revival of classical learning and integration of Arabic scientific texts had produced more sophisticated scholarly approaches to weather interpretation. Figures like Albertus Magnus, c. 1200 to 1280, and his student Thomas Aquinas, 1225 to 1274, attempted to reconcile Aristotelian meteorology with Christian theology, creating coherent frameworks for understanding weather that acknowledged both natural causes and divine purpose. Albertus Magnus, in his commentary on Aristotle's Meteorologica, maintained that weather phenomena operated through natural causes that God had established at creation. Lightning resulted from the explosive interaction of hot and cold exhalations in the atmosphere. Rain formed when water vapor cooled and condensed. Winds arose from temperature differentials. However, God could and did arrange these natural processes to occur at specific times as signs or punishments. This approach, reconciling natural causation with divine purpose, typifies the sophisticated medieval approach to weather phenomena. It allowed for practical weather prediction based on natural signs while preserving theological significance. As Albertus wrote, God created nature to operate in regular ways, but reserves the right to override these regularities for his purposes. The emergence of universities in the 12th and 13th centuries provided new institutional settings for meteorological study. At Oxford, Paris, Bologna, and other early universities, natural philosophy curricula included study of Aristotle's works on weather and atmospheric phenomena. Scholars debated questions like why hail fell more frequently in summer than winter, why some regions experienced more thunderstorms than others, and whether earthquakes and volcanic eruptions shared causes with atmospheric disturbances. University scholars also engaged with Arabic meteorological texts unavailable during the early Middle Ages. Works by Avicenna, Averroes, and Al-Kindi introduced European thinkers to more sophisticated observational techniques and theoretical frameworks. The 13th century English scholar Robert Grosseteste, Chancellor of Oxford University, integrated Arabic optical theory with weather prediction, proposing models for rainbow formation that improved upon Aristotle's explanations. These scholarly developments did not remain confined to university settings, but influenced broader clerical understanding of weather. Parish priests with university education brought more sophisticated meteorological knowledge to their congregations, sometimes tempering apocalyptic interpretations of weather phenomena with natural explanations. Albertus Magnus's popular work, The Book of Minerals, included practical advice for predicting weather based on observable signs, written in accessible Latin for parish clergy. Throughout the medieval period, weather interpretation remained deeply intertwined with biblical prophecy, particularly apocalyptic texts predicting signs before the end times. The Book of Revelation, with its vivid descriptions of celestial disturbances preceding the Last Judgment, provided a powerful interpretative framework for unusual weather events. Revelation's prophecy that the sun became black as sackcloth, the full moon became like blood, and the stars of the sky fell to the earth. Revelation 6:12-13 seemed vividly fulfilled during total solar eclipses, lunar eclipses, and meteor showers. Medieval chroniclers frequently cited such biblical passages when describing unusual celestial phenomena, implicitly or explicitly suggesting their eschatological significance. The challenge for medieval religious authorities was balancing apocalyptic interpretation with pastoral needs. While unusual weather might indeed represent the prophesied signs of the end times, the Church had to avoid encouraging panic or despair that might lead to social breakdown or religious extremism. A sophisticated approach emerged that acknowledged potential apocalyptic significance while emphasizing that only God knew the exact timing of the Last Judgment. Pope Gregory I, c. 540-604, established an influential template for this balanced approach. When 6th century Rome experienced devastating floods, followed by a deadly plague, Gregory organized religious processions and penitential practices while explaining these disasters as both natural occurrences and divine warnings. These temporal afflictions, he preached, are either tests of patience or incentives to repentance. God sends them either to punish sins in this life or to forestall the punishment of future sins. This approach, interpreting disasters as opportunities for spiritual growth rather than simply as punishment, became central to medieval Christian responses to weather extremes. It offered hope that proper religious response might mitigate disasters while acknowledging their theological significance. By the late Middle Ages, parish clergy had access to various texts providing guidance for weather-related pastoral care. The 15th century manual, Manipulus Curatorum, Handbook for Curates, included advice for organizing weather-related processions, blessing fields against storms, and counseling parishioners during weather disasters. These guidelines blended practical advice, theological interpretation, and liturgical resources, equipping priests to address both spiritual and material dimensions of weather crises. The medieval clergy thus served as crucial intermediaries in weather interpretation, preserving ancient knowledge, developing sophisticated theological frameworks, organizing collective responses to weather crises, and helping communities make sense of meteorological phenomena within a coherent worldview. Their role extended far beyond simple superstition or fear-mongering, representing instead a complex integration of practical wisdom, classical learning, and religious meaning-making that helped medieval communities navigate their dependence on weather patterns they could observe but not control. In the spring of 1315, the rains began. Not the gentle, life-giving showers that medieval farmers prayed for, but relentless, cold downpours that transformed fields into shallow lakes and paths into muddy quagmires. Throughout northern Europe, from the British Isles to Russia, from Scandinavia to northern Italy, the deluge continued through summer and autumn. Crops rotted in the fields. Those that could be harvested mouldered in storage barns where the damp could not be kept at bay. The chronicles of the time paint a grim picture. The English monk William Rishanger wrote, "During this year there was excessive rain, scarcely a day passing without rain. The autumn was so wet that the grain could not ripen. Even in November, in many places the harvest was still standing in the fields." His Flemish contemporary Gilles Mises recorded, "In this year, 1315, it rained most marvelously and abundantly during the months of May, June, and July, day and night, or at least every day a little, so that the grain and the vines neither could mature nor be harvested." The following spring brought no relief. The rains continued, and the meager seed grain saved from the previous disastrous harvest failed to thrive in the waterlogged soil. By 1316, famine had taken hold across Europe. Food prices soared to 5 times their normal levels. Reports of crime, infanticide, and even cannibalism appeared in contemporary accounts. Jean de Venette claimed that in some regions, the living ate the dead, while the anonymous Chronicon Commonum Keppenbergensium reported that in Livonia, people were devouring their own children out of hunger. While modern climatologists attribute this catastrophic weather pattern to a transition period in the North Atlantic Oscillation, medieval observers sought explanations within their religious and cosmological frameworks. Many interpreted the Great Famine as divine punishment for collective sin. The French chronicler Anonymal suggested the rains represented God's judgment on the vanity and excess of the nobility. The great lords of England and France had taken to wearing long, tight clothes, contrary to their custom. Therefore, God punished them with the wasting of their goods. Others saw the famine as fulfillment of biblical prophecies about the end times. The book of Revelation described famine as one of the 4 horsemen of the apocalypse, and Matthew's gospel warned that there will be famines and earthquakes in various places before the end. Some radical religious groups declared the famine the beginning of the final tribulations, prompting both religious fervor and social unrest. Institutional religious responses to the famine centered on penitential processions, special masses, and public prayers for divine mercy. Archbishop Walter Reynolds of Canterbury ordered processions throughout his province to placate the anger of God, who afflicts his people for their sins with various punishments through terrible thunder, excessive rain, and other evidences of his wrath. Similar processions occurred across Europe, with clergy and laity walking barefoot through muddy fields, carrying saints' relics believed to have weather-altering powers. Folk superstitions and weather magic flourished alongside official religious responses. In some regions, people revived ancient practices of feeding the wind by tossing flour into the air or setting bread on hilltops. In others, villagers dragged plows to church for special blessings before the spring planting. Protective charms, often syncretic blends of Christian prayers and pre-Christian formulas, were attached to field boundaries and barns. What makes the Great Famine particularly significant for understanding medieval weather superstitions is the detailed documentation of both the meteorological conditions and the social responses. Chronicles, municipal records, manorial accounts, and literary works from this period provide unprecedented insight into how medieval communities interpreted and responded to weather disasters. The famine represents a crucial case study in the intersection of meteorology, religion, and folk belief in medieval Europe. When the Black Death struck Europe in 1347 to 1351, killing an estimated 1/3 of the population, medieval observers naturally sought explanations for such an unprecedented catastrophe. While the immediate cause, what we now know, was Yersinia pestis bacteria transmitted primarily by fleas on rats, remained unknown, many explanations centered on corrupted or poisoned air. The predominant medical theory, drawing on Hippocratic and Galenic traditions, attributed the plague to miasma, noxious air that could transmit disease. This miasma was believed to result from a combination of astrological influences and terrestrial events. In 1348, the medical faculty of the University of Paris issued an influential report attributing the plague to a conjunction of Saturn, Jupiter, and Mars in Aquarius on March 20, 1345. This celestial alignment, they claimed, had heated and corrupted the air, creating the conditions for pandemic disease. According to this theory, the corrupted atmosphere entered human bodies through respiration and pores, disrupting the balance of the four humors and causing the characteristic symptoms of the plague. The theory explained why the disease seemed to travel on the wind, affecting some regions while temporarily sparing others. Beyond these learned explanations, popular beliefs connected the plague with unusual weather phenomena that had preceded it. The years before the Black Death had featured a series of meteorological anomalies across Europe: floods, droughts, erratic temperatures, and strange atmospheric effects. In 1346, an earthquake had struck northern Italy, interpreted by many as releasing poisonous vapors from the earth that contributed to the subsequent disease. The Florentine chronicler Giovanni Villani recorded a particularly striking atmospheric phenomenon in 1348. On the 4th of June, for a third of the night, there appeared in the air over Florence a great fiery pillar, which seemed to many a certain presage of the pestiferous disease which followed. While modern meteorologists might identify this as an unusual aurora borealis or meteorological display, for Villani and his contemporaries, it represented a visible manifestation of the atmospheric corruption causing the plague. Protective measures against the plague often focused on counteracting this corrupted air. Physicians recommended burning aromatic herbs and woods to purify the atmosphere. People carried pomanders, perforated containers filled with spices, herbs, and resins, to breathe through when traveling through potentially contaminated areas. Some wealthy individuals fled to rural mountain retreats, where the air was believed to be pure and less susceptible to corruption. Religious interpretations attributed the atmospheric corruption to divine punishment for human sin. The German flagellant movement, which gained thousands of followers during the plague years, practiced public self-flagellation to appease God's wrath. Their manifesto explicitly connected the plague with divine meteorological intervention. God has permitted this pestilence because of the sins of men. He has poisoned the air to destroy sinful humanity. Jewish communities across Europe became targets of violence, accused of poisoning wells or corrupting the air through magical practices. These anti-Semitic persecutions, while driven by long-standing prejudices, gained particular force because they offered a human scapegoat for what seemed an atmospheric or meteorological catastrophe. The Black Death thus represents a crucial case study in how medieval societies interpreted the relationship between atmospheric phenomena, disease, and divine intervention. The pandemic's apparent connection to unusual weather patterns reinforced beliefs in meteorological omens, while the miasma theory provided a pseudo-scientific framework linking celestial events to terrestrial calamities. Not all extreme weather events in medieval Europe brought only disaster. The periodic freezing of the River Thames in London produced one of the most remarkable cultural responses to extreme weather, the Thames Frost Fairs. When the river froze solid enough to support weight, a phenomenon that occurred periodically throughout the medieval and early modern periods, Londoners transformed potential hardship into celebration. Temporary villages sprang up on the ice, complete with streets, shops, taverns, and even printing presses. The first documented frost fair occurred in 1608, but evidence suggests similar, smaller celebrations during earlier medieval freezes. The freezing of the Thames represented an inversion of natural order, water becoming solid, a river becoming land, that medieval people found both alarming and fascinating. In a society that interpreted unusual natural phenomena as potentially significant omens, such dramatic transformation of a major waterway demanded explanation and response. Chronicles record various superstitions surrounding the frozen river. Some believed that walking across frozen water without making the sign of the cross risked encountering water spirits trapped beneath the ice. Others maintained that drinking melted ice from a frozen river during Candlemas, February 10th, would prevent fever throughout the year. Games played on the ice were thought to ensure fertility and abundant harvests in the coming season, connecting the winter freeze with agricultural success. Religious authorities integrated the freezing into Christian frameworks, sometimes declaring special services of thanksgiving that God had provided a temporary bridge, or interpreting the freeze as a sign of divine favor, showing that even the elements could be tamed through faith. Parish records from Riverside London churches show increased donations during freeze periods, suggesting heightened religious sentiment. While modern climatologists attribute Thames freezing events to the colder temperatures of the Little Ice Age, approximately 1300 to 1850, medieval Londoners looked to both natural and supernatural explanations. Astrological treatises connected river freezing with specific planetary alignments. Folk wisdom developed elaborate prediction systems based on animal behavior and plant growth patterns in preceding autumn months. What makes the Thames Frost Fairs particularly significant for understanding medieval weather superstitions is how they demonstrate adaptive cultural responses to extreme conditions. Rather than merely surviving the freezing river, which disrupted normal commerce and water access, Londoners created elaborate cultural traditions, transforming meteorological hardship into communal celebration. The fairs represent a sophisticated cultural adaptation to unpredictable weather extremes, one that acknowledged the event's extraordinary nature while incorporating it into social and religious frameworks. While not strictly meteorological phenomena, earthquakes were closely linked to weather events in medieval understanding. Drawing on Aristotelian theory, Medieval scholars believed earthquakes resulted from trapped winds within the earth, essentially the same processes that caused storms in the atmosphere, occurring instead beneath the ground. This connection appears clearly in the term used for earthquakes in many medieval texts. Terrae motus, earth movement, was often described as caused by terrae spiritus, earth breath or wind. The 13th century Encyclopedia de Proprietatibus Rerum by Bartholomeus Anglicus explains, "The cause of earthquakes is wind enclosed in the hollow places of the earth. When this wind cannot break out, it shakes the earth with its strong blowing and breaketh out with strong blasts." Because medieval cosmology viewed the earth as a living entity with breath and humors analogous to the human body, earthquakes were sometimes interpreted as the earth shivering with fever or expressing distress. Just as human illness might manifest through irregular breathing, the earth's sickness could appear as seismic activity. When an earthquake struck England and northern France on May 11, 1382, powerful enough to damage the stone walls of Canterbury Cathedral, chroniclers connected it with atmospheric conditions. The Westminster Chronicle reported, "The air before the earthquake had been remarkably calm and mild, so that everyone wondered at the sudden change, seeing that there was no rainstorm or wind, as usually happens when a big earthquake is due to take place." Religious interpretations of earthquakes drew on biblical precedents, particularly Matthew 27:51, which described an earthquake accompanying Christ's crucifixion, and Matthew 24:7, which listed earthquakes among the signs preceding the end times. When earthquakes coincided with other unusual phenomena, comets, aurora, unseasonal weather, they were especially likely to be interpreted as apocalyptic signs. Protective measures against earthquakes often combine practical and supernatural elements. Architecturally, some regions developed building techniques intended to withstand seismic activity. Spiritually, special prayers and processions similar to those used during storms were employed to seek divine protection. The liturgy for these earthquake processions explicitly connected seismic and meteorological phenomena as related manifestations of divine power. Folk beliefs surrounding earthquakes included various divinatory practices. The direction from which earthquake tremors seemed to come was thought to predict the direction from which future threats would arrive. The season and time of day when earthquakes occurred supposedly indicated which crops would fail or which diseases would become prevalent in the following months. These beliefs reinforced the perceived connection between seismic activity and subsequent weather patterns or agricultural outcomes. Throughout medieval Europe, flooding represented one of the most common and devastating natural disasters, threatening communities from the lowlands of the Netherlands to the alpine valleys of Switzerland. Biblical precedent, specifically Noah's flood, provided a powerful interpretive framework for these events, casting floods as potential instruments of divine judgment. When the North Sea surge of 1287, known as St. Lucia's flood, devastated the Dutch coast, drowning an estimated 80,000 people, chronicles explicitly compared it to Noah's deluge. The Dutch Egmont Chronicle described how the sea, rising beyond its usual level, flooded all the coastal lands, destroyed many villages, drowned many thousands of people, and caused damage beyond calculation. Not since the time of Noah has such a flood been seen in our lands. Religious authorities interpreted such catastrophic flooding as divine punishment requiring collective repentance. After major floods, communities typically organized penitential processions, special masses, and communal prayers. Church records from flood-prone regions show increased donations for votive candles, masses, and religious art depicting saints associated with water protection, particularly Saint Nicholas, patron of sailors and fishermen, and Saint Florian, invoked against floods. Folk superstitions surrounding flood prediction were particularly elaborate in regions regularly threatened by inundation. Communities along the Rhine developed systems for interpreting unusual watercolors, sounds, or ripple patterns as warning signs. In Venice, the behavior of fish in the lagoon was carefully observed for indications of approaching acqua alta, high water. Alpine villagers monitored the appearance of springs and the melting patterns of snow for signs of potential flash floods. Protective measures against flooding combined practical engineering with religious and magical practices. Physical defenses included dikes, levees, and water diversion channels, many constructed and maintained by monastic communities who combined hydraulic engineering with prayers for divine protection. In the Low Countries, water management boards developed sophisticated systems for controlling flood risk, while simultaneously organizing religious processions along dike routes. Magical protections included placing blessed objects at water boundaries, carving protective symbols on bridges or waterside buildings, and burying specific items at strategic points. Boundary stakes marking flood control areas were often carved with crosses or saint symbols, combining practical marking with supernatural protection. Some communities maintain traditions of feeding the water with ritual offerings at specific times of year to prevent future flooding. Chronicles record various omens believed to precede major floods. Unusual behavior among waterbirds, frogs appearing in unexpected locations, or wells suddenly changing flavor or temperature were all interpreted as flood warnings. Atmospheric signs, particularly unusual fogs, strange cloud formations, or unseasonable rainbows, were similarly viewed as potential flood indicators. The 1342 St. Mary Magdalene's flood, which devastated Central Europe, was reportedly preceded by dragons fighting in the air, likely an unusual atmospheric phenomena, such as waterspouts or tornadic activity, that medieval observers interpreted through available mythological frameworks. Multiple chronicles mention blood-red skies before major floods, possibly referring to dust-laden sunsets or unusual light refraction through storm systems. What distinguishes medieval responses to flooding from mere superstition is their integration of careful empirical observation with religious and cultural frameworks. Communities in flood-prone regions developed sophisticated understanding of hydrological patterns, recognizing correlations between upstream conditions and downstream flooding, between certain atmospheric conditions and subsequent precipitation. These practical insights were embedded within interpretive systems that also addressed the existential and theological questions raised by devastating natural disasters. Medieval Europe's temperate climate made severe storms a regular feature of life, from the Atlantic gales battering Ireland and Britain to the violent Mediterranean tempests threatening shipping and coastal communities. Medieval understanding interpreted storms not merely as meteorological events, but as manifestations of cosmic conflict, tangible evidence of battles between spiritual forces. Drawing on both biblical imagery and lingering pre-Christian traditions, medieval Europeans often perceived storms as battlegrounds where angels contested with demons for control of the atmosphere. The sudden darkness of storm clouds, the crash of thunder like distant armies clashing, the destructive power of lightning and hail, all suggested supernatural warfare rather than purely natural processes. This interpretive framework appears clearly in protective practices against storms. Church bells were rung during severe weather, partly as practical warning systems, but primarily because their consecrated sound was believed to drive away demons manipulating the storm clouds. The traditional inscription on medieval church bells, fulgura frango, I break the lightning, reflects this belief in their protective power. Similarly, blessed candles, particularly those consecrated on Candlemas, February 2, were lit during storms to dispel the darkness associated with demonic influence. Holy water was sprinkled around vulnerable buildings, and prayers to specific storm-protecting saints, Barbara against lightning, Clare against high winds, Medard against excessive rain, were recited with particular fervor. Monastic chronicles record numerous instances where storms were interpreted as targeted spiritual attacks rather than random weather events. When lightning repeatedly struck church buildings, medieval observers might conclude that demons were specifically targeting sacred spaces, or alternatively, that God was warning against corruption within those institutions. The monastery of St. Gall recorded a remarkable storm in 937 CE, where a tempest of extraordinary violence arose suddenly, and lightning struck the church tower 3 times in succession, though by God's mercy it did not ignite. Simultaneously, the demon was seen sitting on the tower in the form of a great black bird. This account reveals how visual phenomena during storms, perhaps an actual large bird or peculiar cloud formation, were integrated into spiritual interpretation. Weather magic specifically targeting storms flourished throughout medieval Europe, despite official church condemnation of magical practices. In alpine regions, special bells called weather bells, Wetterglocken, were rung specifically to disperse threatening storms. Crosses made from Palm Sunday branches were burned during thunderstorms in many regions. Stone axes and other prehistoric tools found in fields were identified as thunderstones, believed to be physical remnants of lightning strikes, and kept as protective talismans against future storms. Professional storm chasers, or weather makers, appeared in some European regions, claiming power to divert hail or destructive winds away from their clients' fields, typically for payment in grain or wine. These individuals used various techniques combining quasi-religious rituals with empirical weather observation, creating what amounted to an alternative system of weather management outside official religious frameworks. Church authorities vacillated between condemning such practitioners as superstitious or demonic and incorporating aspects of their practices into officially sanctioned rituals. By the late Middle Ages, many dioceses had developed official blessing ceremonies for fields threatened by storms, integrating elements of folk practice into liturgical frameworks. What makes medieval storm interpretation particularly significant is how it reveals the perceived thinness of boundaries between physical and spiritual realms. Storms manifested at this boundary, physical phenomena with spiritual significance, natural events with supernatural causes. In this understanding, appropriate response to severe weather necessarily addressed both material and spiritual dimensions, combining practical preparations with religious and magical protections. If floods represented divine punishment through excess water, droughts manifested divine displeasure through its absence. Throughout medieval Europe, extended dry periods threatened agricultural communities with crop failure, water shortages, and ultimately famine. Biblical precedents, particularly the 3-year drought during Elijah's time, provided frameworks for interpreting these events as divine judgments, requiring specific religious responses. The Anglo-Saxon Chronicle entry for 1095 captures the terror drought inspired. In this year there was much unseasonable weather which greatly damaged the fruits of the earth, and such great misfortune in weather as no man remembered before, for there was thunder and lightning which killed many men, and it grew worse and worse with all kinds of misfortune. May God Almighty better it when it shall be His will. Religious responses to drought centered on special prayers, processions, and rituals specifically requesting rain. Rogation processions, where clergy and parishioners walked the boundaries of their fields while praying for fertility and protection, took on special urgency during drought periods. Saints particularly associated with rainfall or agricultural abundance received increased veneration and offerings during dry periods. The ritual of beating the bounds, walking parish boundaries while striking landmark stones with sticks, gained additional significance during droughts. This practice, combining practical boundary maintenance with religious blessing, was believed to reconnect the community with divine protection and restore proper order between heaven and earth. Many regions maintain specific drought-breaking rituals, combining Christian and pre-Christian elements. In parts of Spain and southern France, the custom of dipping the saints involved immersing statues of particular saints in rivers or lakes after processions and prayers for rain. If rain followed, the saint received special veneration. If drought continued, additional saints might be baptized until results appeared. Some communities maintain traditions of rain stones, particular rocks believed to produce rainfall when properly treated. These practices, condemned by church authorities as superstitious, nevertheless persisted in many rural areas. The procedures typically involved pouring water over the stones while reciting specific prayers or formulas, a form of sympathetic magic, attempting to prompt heaven to mirror the ritual action. Divinatory practices surrounding drought prediction were particularly elaborate in Mediterranean regions, where seasonal rainfall patterns made accurate forecasting crucial for agricultural planning. Careful observation of specific constellations, cloud patterns on certain feast days, or animal behaviors at key calendar points created complex predictive systems combining astronomy, meteorology, and folk wisdom. These prediction and response systems reveal sophisticated adaptive mechanisms for managing environmental uncertainty. While modern observers might dismiss rain processions or saint dipping as mere superstition, such practices served important psychological and social functions, providing communities with structured activities during crisis periods, reinforcing social cohesion, and creating frameworks for understanding and responding to environmental threats beyond human control. As Europe transitioned from the Middle Ages into the Renaissance and early modern period, weather superstitions demonstrated remarkable persistence, adapting to new intellectual frameworks rather than simply disappearing. The scientific revolution of the 16th and 17th centuries gradually transformed understanding of meteorological phenomena, but folk beliefs, religious interpretations, and traditional weather prediction methods continued alongside emerging scientific approaches. When unprecedented storms battered Europe in 1570, destroying the Dutch coastal defenses and flooding vast areas of the Low Countries, pamphlets circulated attributing the disaster to divine punishment for religious conflicts during the Reformation. Despite the growing influence of mechanical philosophy and natural science, such providential interpretations remained common throughout the 16th and 17th centuries. The astrometeorological tradition, linking celestial movements with weather patterns, actually expanded during the early modern period. The development of printing made astrological almanacs widely available, with annual weather predictions based on planetary positions reaching broader audiences than ever before. Figures like Tycho Brahe, while developing more rigorous observational astronomy, continued to accept connections between celestial and meteorological phenomena. Court astrologers retained responsibility for weather prediction alongside political and personal horoscopes. When the Spanish Armada was destroyed by storms in 1588, Both Protestant and Catholic commentators interpreted the event providentially. Protestants as divine protection of England, Catholics as unfortunate but not necessarily meaningful misfortune. Elizabeth Pfeffer's astrologer John Dee had allegedly predicted unfavorable weather for the Spanish fleet, demonstrating the continuing prestige of astrological meteorology. Religious weather interpretations adapted to post-Reformation theological frameworks. Protestant theology emphasized direct divine sovereignty over nature, potentially reinforcing providential interpretations of weather events. Luther himself described severe storms as potentially the work of demons, requiring prayer rather than merely natural explanation. Catholic Counter-Reformation theology, meanwhile, emphasized the intercession of saints and the Church's role in mediating divine protection against adverse weather. Traditional weather prediction methods based on animal behavior, seasonal patterns, and direct observation not only survived, but were systematized in early agricultural manuals and almanacs. Works like Thomas Tusser's 500 Points of Good Husbandry, 1557, preserved medieval weather lore while integrating it with classical sources and contemporary observation. The scientific revolution gradually transformed understanding of meteorological phenomena, but this transformation occurred unevenly across different social groups and regions. The development of meteorological instruments in the 17th century, thermometers, barometers, hygrometers, and anemometers, created new possibilities for quantitative weather observation, complementing and sometimes challenging traditional qualitative methods. When Edmund Halley published his landmark study of trade winds and monsoons in 1686, he demonstrated how methodical observation and physical principles could explain weather patterns previously attributed to divine or astrological causes. Similarly, Robert Hooke's detailed observations of cloud formations and weather conditions at the Royal Society established frameworks for systematic meteorology independent of supernatural explanation. Yet these scientific developments influenced popular weather beliefs only gradually. In rural communities especially, traditional methods of weather prediction and interpretation persisted alongside emerging scientific approaches. The farmer consulting a printed almanac might simultaneously observe animal behavior and conduct traditional weather rituals, not seeing these approaches as contradictory, but as complementary systems addressing different aspects of weather phenomena. Church bells continued to be rung during storms well into the 19th century, long after scientific understanding of lightning had demonstrated the danger this practice posed to bell ringers in tall towers. Benjamin Franklin's invention of the lightning rod in 1752 met resistance partly because it seemed to interfere with divine sovereignty over lightning, replacing prayer and penitence with a mechanical solution. The gradual transition from religious to natural explanations of weather phenomena reveals interesting patterns of adaptation rather than simple replacement. When the devastating Lisbon earthquake and tsunami struck on All Saints' Day 1755, the event sparked profound theological debate. Traditional providential interpretations, divine punishment for sin, competed with emerging natural theology, understanding disasters as consequences of beneficent natural laws established by God, and with purely naturalistic explanations. Weather superstitions proved particularly persistent in maritime communities, where weather prediction remained crucial for survival well into the modern era. Sailors maintained elaborate systems of weather lore alongside increasingly scientific navigation methods. The traditional rhyme, "Red sky at night, sailor's delight, red sky in morning, sailor's warning," persisted because it captured genuine correlations between sunset-sunrise conditions and subsequent weather in mid-latitude sailing regions. agricultural communities similarly maintained traditional weather prediction methods alongside modern meteorology. The English tradition of counting the cuckoo's call to predict how many weeks of summer remained continued into the 20th century. Planting by the phases of the moon, a practice with medieval and ancient roots, remains common in some farming communities today, with some scientific studies suggesting potential correlations between lunar phases and plant growth. Even in our scientifically advanced society, echoes of medieval weather beliefs persist, not merely as superstitious holdovers, but as psychologically meaningful responses to meteorological phenomena that remain partially outside human control. Despite sophisticated forecasting models and satellite imagery, weather continues to evade perfect prediction or control, occasionally manifesting destructive power that dwarfs human capability. When Hurricane Katrina devastated New Orleans in 2005, some religious leaders interpreted the disaster as divine punishment for the city's moral character, a perspective with direct medieval parallels. Climate change discourse sometimes adopts quasi-religious frameworks of sin, retribution, and redemption that echo medieval interpretations of weather disasters as moral events requiring spiritual response. The psychological functions served by medieval weather superstitions, providing explanatory frameworks for unpredictable phenomena, suggesting potential control mechanisms, and integrating physical events into moral and spiritual meaning systems, remain relevant in contemporary society. Modern weather rituals, from the Groundhog Day ceremony to rain dances performed at sporting events during droughts, fulfill similar psychological needs to their medieval counterparts. Meteorological terminology itself preserves traces of earlier animistic or supernatural perspectives. We speak of rogue waves, killer storms, and weather systems that threaten or spare communities. Language that subtly personifies meteorological phenomena in ways medieval people would have recognized. Contemporary descriptions of tornadoes as monsters or hurricanes as beasts reveal how easily we slip into frameworks that attribute agency or intention to weather phenomena. The persistence of traditional weather sayings, March comes in like a lion and goes out like a lamb, rain before 7, clear by 11, demonstrates the continuing appeal of memorable, accessible weather wisdom alongside scientific meteorology. These sayings, many with medieval origins, survive because they combine empirical observation with cultural meaning in forms more immediately useful for daily decision-making than abstract meteorological data. Contemporary interest in weather sensitivity, the influence of meteorological conditions on health, mood, and behavior, echoes medieval beliefs about weather's effects on humoral balance. While modern research investigates barometric pressure effects on arthritis or seasonal light variation on mood disorders, the underlying recognition of intimate connections between human bodies and atmospheric conditions has precedence in medieval medical and popular traditions. The medieval legacy in modern meteorology extends beyond superstition to observational practice. The emphasis on patient, consistent weather recording in medieval monastic chronicles prefigured modern meteorological record-keeping. The integration of weather observation with agricultural planning in medieval almanacs anticipated modern agricultural meteorology. The systematic correlation of astronomical and meteorological phenomena in medieval astrometeorology, while based on incorrect causal theories, nevertheless established important precedents for recognizing larger environmental patterns. Perhaps most significantly, medieval weather interpretation reminds us that meteorology serves not merely practical, but existential functions, helping people make sense of their place in a universe where atmospheric forces dramatically impact human life, yet remain beyond complete human understanding or control. While our explanatory frameworks have transformed, weather phenomena continue to prompt fundamental questions about meaning, purpose, and humanity's relationship with the natural world. As we conclude our journey through the labyrinth of medieval weather beliefs, we find ourselves not among primitive superstitions that modern science has simply dispelled, but within a coherent worldview that integrated empirical observation, religious understanding, and cultural meaning in sophisticated ways. Medieval people were neither ignorant victims of weather phenomena nor passive recipients of religious dogma about meteorological events. Instead, they actively created complex interpretive frameworks that served practical needs while addressing profound questions about divine purpose, natural order, and human responsibility. The medieval weather mindset developed at the intersection of three powerful influences: the visceral experience of meteorological vulnerability, the intellectual heritage of classical natural philosophy, and the theological framework of Christianity. From this crucible emerged understanding that might appear contradictory to modern sensibilities, simultaneously attributing weather to natural causes explained by Aristotelian physics and to divine purpose expressed through providential intervention. Fear undeniably shaped medieval weather beliefs. In a primarily agricultural society without modern protective infrastructure, weather disasters could destroy not merely property, but entire communities. The medieval peasant watching storm clouds gather over ripening fields faced not an inconvenience, but a potential catastrophe. Chronicles and sermons reveal profound anxiety about weather, from thunder psychology, fear of lightning, to collective dread of drought. These fears found expression in elaborate protective rituals, from ringing consecrated bells to carrying sacred relics through fields. Yet medieval weather response transcended mere fear. Faith provided frameworks for understanding meteorological phenomena within cosmic order, rather than as random terrors. Weather events, even destructive ones, had meaning within divine providence. Storms might represent divine punishment, but this interpretation made them comprehensible rather than arbitrary. Drought might signify God's displeasure, but this suggested potential remedy through proper religious response. Faith transformed unpredictable meteorological phenomena from meaningless suffering into purposeful communication within an ordered universe. Alongside fear and faith stood practical wisdom accumulated through generations of observation. Medieval weather lore contained genuine meteorological insight, capturing correlations between observable phenomena and subsequent weather patterns. The shepherd who recognized approaching storms in animal behavior, the sailor who predicted winds from cloud formations, the farmer who timed planting by seasonal indicators, all demonstrated sophisticated environmental knowledge based on careful observation rather than mere superstition. What distinguished medieval understanding from modern meteorology was not the absence of empirical observation, but the integration of such observation within religious and cosmic frameworks. Weather was simultaneously physical and spiritual, natural and supernatural. Thunder resulted from colliding air masses, physical, while potentially signifying divine warning, spiritual. Drought occurred through natural processes, meteorological, while possibly representing divine judgment, theological. This integrated perspective created remarkably adaptive responses to weather challenges. Medieval communities facing drought might simultaneously dig irrigation channels, practical, organize religious processions, spiritual, consult almanacs for planting advice, intellectual, and maintain traditional rainmaking rituals, cultural. Rather than representing confused thinking, this integrated approach addressed different dimensions of weather crises: practical needs, psychological comfort, social cohesion, and existential meaning. The study of medieval weather superstitions offers valuable insight not merely into past societies, but into enduring aspects of human nature. Our need to create meaning from natural phenomena, our desire for control over unpredictable forces, and our tendency to integrate new knowledge within existing frameworks rather than simply replacing older understandings. Medieval weather interpretations reveal humanity's profound need for explanatory frameworks that provide not just causal explanations, but meaningful narratives. When lightning struck a cathedral, medieval observers wanted to know not merely the atmospheric mechanisms, but the purpose. Why this building? Why this moment? What message was being conveyed? This search for meaning persists in contemporary responses to natural disasters, from theological interpretations of hurricanes to metaphorical descriptions of pandemic viruses as punishing human environmental transgressions. Similarly, medieval protective rituals against adverse weather, from processions to bell ringing to prayer, fulfilled deep psychological needs for agency in the face of uncontrollable forces. These practices provided structured activities during crisis periods, reinforced community bonds, and created the crucial sense that something could be done when physical control proved impossible. Contemporary parallels appear in disaster response rituals, from candlelight vigils after hurricanes to communal rebuilding ceremonies, which similarly address psychological and social needs beyond physical reconstruction.